dear friend Murugu, someone I know has abiding passion for manufacturing, dignitaries on the dais, in the audience, ladies and gentlemen. It's an honor for me to be here today to share a few comments with all of you on a very important subject for India, manufacturing. I was privileged through my career naturally in the auto industry to be very closely involved with manufacturing for much of my life. But equally, during a stint on the National Manufacturing Competitiveness Council and also on the governing board of CMTI, which is where actually I've come to interact many amongst this audience, and I've come to appreciate the passion, the commitment, and the efforts you have undertaken in manufacturing all these years. I think IMTA has done yeoman service to the country, and I hope in the years to come, IMTA will have an even bigger role to play in India's development. It is also true to recognize that as much as we have talked about celebrating and encouraging manufacturing in India, we have a long way to go. During my time on the NMCC, we'd come up with a lot of policies related to manufacturing, something that ultimately made its way through the Planning Commission. But sadly, if you look at what had been identified as goals for the country, importantly, moving manufacturing significantly up in its contribution to India's GDP, we're still a long ways from that goal, and there's a lot of work for us to do. Most recently, there has been the important platform that has been identified of Make in India, outlining many things that the country should be doing to enhance its position globally in manufacturing. But here too, I think all of us who have been close to manufacturing will have to confront the reality that we still have a lot to do. And today we are at the dawn of what is supposed to be a new industrial policy, and one truly hopes that this industrial policy will bring out elements that will accelerate manufacturing as an important contributor to India's economy. Now, in my comments today, let me start with this picture. This is the picture of the god in Roman mythology called Janus. Janus is a god that is depicted with two faces, one looking backwards and one forwards. In some ways, I think this lord of Roman mythology, Janus, should have aptly been a patron saint of Chennai. For those of you who are from outside Chennai, know the penchant of Chennaites to look backwards, linger on their legacy and heritage. But there is value to this. And in fact, as this symbol depicts, I can see no better way to build strategies for the future than to couple the wisdom of experience of past years with the imagination and the energy of youth. And indeed, this is what this figure depicts. And so in my talk today, no doubt drawing on a lot of milestones from the auto industry, I'd like to talk a little bit about how have we evolved productivity in manufacturing through these years, and if that provides any kind of guidance of where we should be going in terms of taking manufacturing productivity further in the years to come. Of course, it's a cliche to say that most of our concepts of manufacturing productivity probably go back, at least in the recent terms, to the advent of mass manufacturing. Mass manufacturing was not simply a matter of just manufacturing to scale. I mean, if we had not gone on to the concept of standardization, today we talk about geometric dimensioning and tolerancing. These were implicit principles in enabling mass manufacturing to arrive. It had to do with how we dealt with labor. You know, Henry Ford famously promised his labor a wage that could afford each one of his factory workers to be able to buy the car they built on the line. So it was not just a matter of building to scale, but it was thinking through standardization, concepts of manufacturing, labor policy, and of course, orchestrating a large supply chain. And of course, there are few better examples of how this mass manufacturing led to productivity improvements than the time when the US went into the Second World War. As many of you know, President Roosevelt was very wary of taking the US into the Second World War, and as a result, it was a little unplanned and it was rather late. But they had to, once they decided to get into the war, they had to ramp up their war machinery, and they had to get into manufacturing very rapidly. Folklore talks about how a lot of the auto industry was roped in to be a part of the US defense establishment. So Sherman tanks were built by the Chrysler Corporation, Rolls-Royce Merlin engines were built by General Motors, and in this picture you see the B-24 Liberator bombers built in the Ford plant in Willow Run. Now what's interesting about this example of productivity is, in 1939, the entire fleet of the RAF, the Royal Air Force, comprised 620 aircraft. Once the US decided to get into war and ramp up manufacturing, by 1942, this plant in Willow Run was making 650 aircraft each month. The entire fleet of the RAF was being turned out every month, and these were not small planes, as you can see, huge 4-engine bombers, and they were making 20 a day. You know, today when we are talking about productionization of the light combat aircraft, we're lucky if we can make one a week. And here, with primitive technology in the Second World War, they were making 20 Liberator bombers a day. So this is the potential of how productivity was extracted by leveraging the principles that we had learned in mass manufacturing. During my tenure as chairman of the joint venture with Nissan, I had many occasions to visit Japan and often visited plants. And this is one particular plant that I was particularly struck by. This is the Nissan Shatai plant, where they make a very bewildering combination of products. They build 5 different platforms. But what was astounding to me was that in reaching this plant, we had to drive through suburbs, past houses, small roads, and all of a sudden there was an auto plant there. And this plant was crammed into something like 180 acres of land. If we were in Tata Motors or Ashok Leyland or God knows any of the other companies, if we were contemplating a plant to manufacture 280,000 vehicles, we would have started with a blueprint that says, I need 500, 600 acres of land. And yet here, within 180 acres of land, they were producing about 280,000 cars, mind-boggling complexity of 5 platforms, various things, everything from small cars to delivery vans. Remarkably efficient in terms of how they have used land and precious resources. In fact, I would maintain that the Japanese excellence, their cultural excellence in manufacturing has stemmed from these kinds of resource constraints. Of course, this culture led to what much of the world has gone to Japan to learn, this whole idea about lean operations, lean manufacturing, made famous by the Toyota productivity system. And something else that that system taught us, which is that as you work with tighter and tighter constraints and you improve efficiency in manufacturing, you not only improve productivity, but you also improve quality. And of course, it's very encouraging now to see so many industries in India aspire to and very often win the Deming Prize for quality. I think this has taught us around the world a tremendous amount of how we might leverage a combination of productivity and quality from operations. But of course, it's not, life's never easy, and things get complicated. People want more and more variety. This is a simple chart that says how the number of Audi models have grown over the last few years. And what you can see, of course, is that more and more variety and more models keep getting built. In fact, I have this joke with this friend of mine who's a board member of Daimler. I tell him that Daimler-Benz today, they used to make a very simple product lineup. You had the C-Class Mercedes, you had the E-Class Mercedes, and you had the S-Class Mercedes. Today, you can take any three alphabets and you jumble them up in any combination, and there is a Mercedes car for that. So you have a CLA, you have a CLS, you have a GLS, you have a GLE, and you have a CLS. You can take any combination of three letters, jumble it up, and you've got a Mercedes. And in case you try this at home and you find that there is a combination for which a car does not exist, please don't tell the Daimler-Benz planning. They will probably rush and build one more car to fit that gap. But this is the fact of life today. We have variety because consumers increasingly are demanding variety. So manufacturing is now challenged by not just managing productivity, but managing variety along with productivity in its operations. And so this led to the advent, of course, of automation. I have been privileged in my career at GM Research to have worked with some of the people who were involved in the earliest stages of automation. In fact, the first robot on a production line was installed in GM's plant in Lordstown, where it was picking and sorting hot forgings that were coming off the production line. And from those days, of course, we have gone to harness automation as an important tool for productivity. And I know there are many in this audience here who have played an important role in making this happen even in India. But this variety has continued to grow, and it might look like I'm picking on Mercedes today, but today, if you take just one platform in Mercedes, the E-Class platform, they are today built in such mind-boggling variety that it puts tremendous strain on any kind of a manufacturing operation. In auto manufacturing, we have this concept called build combination. A build combination is the expression of a vehicle by picking through one of its multiple combinations with which it can be built. For example, a red car, a blue car, a diesel car, a petrol car, a four-door or two-door, and so on. So when you look at the build combinations today that we are demanding from production, it's astounding. And I'm going to give you a test here. You know, how many possible E-Class Mercedes could one possibly build just out of one platform? Of course, it's a very large number. Anybody want to take a guess? Million, billion? Okay, the answer is a trillion. You can build a trillion different E-Class Mercedes, no two of which are identical. And this is what we have driven complexity in manufacturing to. And so, apart from making sure that we achieve the kind of productivity that we need, we also have to cater to a manufacturing organization that can deal with this kind of variety. And it's getting worse because, you know, this is the age when we're talking about personalization. We all want personalized products. We want personalized services. I found this to be an extremely interesting example. Pardon me for bringing women's shoes into a manufacturing conference. But this is an organization that allows people to custom design their own shoe online. Now, this is a remarkable test case for auto engineers. If I were to go to a Harley-Davidson and tell them, please tell me how I can configure my own Harley-Davidson motorcycle, I don't think they'll come anywhere close to this company that makes shoes. What this company allows you to do is to go online and literally dynamically design the shoe that you want. It's backed by on-the-spot visualization and animation, so you can see the shoe from all angles. You can add color, you can add texture, you can add material, you can add style, you can add straps, whatever you want. Dynamically see it on the tube with virtualization of the image. But now get this. Dynamically, it can tell you what is the price of the shoe and the delivery date. So I challenge any automaker to do an on-the-fly pricing of a product that is randomly configured and promise a delivery date within a couple of weeks to a consumer in the US. So this is how we are moving towards. So if you go to a Mercedes showroom and say, I want an AMG Mercedes, but I want the AMG plaque to be replaced by an aluminum applique, and I want carbon fiber disc. I mean, people want to do this, but they want to do this, and they want the product as soon as possible. And so the challenge for manufacturing has grown manifold because of these kinds of challenges. Thankfully today, we're able to find some progress towards this. I work closely with the advisory board of John Deere, and we're seeing for manufacturers like Deere, particularly when you have one-offs and two-offs, you've got a combine harvester in the Philippines, you can imagine the challenge of maintaining parts supply for service and service operations. So we're beginning to now start to deal with production to the lot size of one. Sometimes it is additive manufacturing, sometimes it is a combination of additive mold making and castings. But we're learning very quickly not only to do mass manufacturing, but also to do very rapid manufacturing to a lot size of one. And of course, fiction or romance today believes that we will soon be able to 3D print our own car. We may still be quite a ways from there, but I don't think we're going to be far away from 3D printing certain aspects of your car. So you could possibly personally design elements of the interior or elements of the exterior appearance and make sure that the car manufacturer incorporates that in the final build. Now, this is therefore meant a need to look at productivity, not just from volume of production, but emanating from how we're orchestrating manufacturing, as I say, from the top floor to the shop floor. So this means orchestration of everything related to the supply chain, on the plant manufacturing, and dealing with the distribution chain, on top of the kind of analytics, the kind of data, the kind of oversight one needs to make sure that data is adequately shared between supervisors on the factory floor all the way to CEOs in the top floor. Now, unfortunately, the domains haven't stopped with the plant. Domains haven't stopped with the geography of production. Because increasingly, what we're finding is organizations are becoming more and more global. The Boeing 787 program, for instance, is built with 2.3 million parts. And 80% of those parts are outsourced. In fact, adding Fuji, Mitsubishi, and Kawasaki, and you look at the role of these three manufacturers in the 787, and they probably build more of the 787 than Boeing themselves. So how do you now not only manage shop floor to top floor, but you're also having to manage an orchestration of a global supply chain? Many, many years ago, and I'm talking now 15 years ago, when Boeing was doing the 777 program, already it used to be a bit of a wow factor in the industry, because Boeing used to say that they update their PLM data structure every 24 hours. So you can imagine the entire 2.3 million parts from so many different suppliers all over the world, and the product expression is getting updated every night in Seattle. But the value, of course, has come from being able to pick the best in the world. So Boeing didn't go to Fuji or Mitsubishi or Kawasaki for any other reason other than that they had productivity. And as a result of engaging these kinds of suppliers into their global supply chain, they were vastly improving the productivity of Boeing and the competitiveness of the 787 against competitive Airbus products. So globalization has further pushed up the challenge. And then, of course, there is the challenge from the product itself that is getting more complex. Increasingly today, we're seeing our products defined not so much by their physical attributes and their physical properties, but also by their software and their electronic systems. So here's another test case for you. You see three products featured here. The lowest is the F-22 stealth fighter from Boeing, the Raptor. and then you have the 787 and the Mercedes S-Class. A product like the F-22 is obviously a very complex product. It's a stealth fighter. It can do super cruise. It has advanced weapon systems, and it takes 5 million lines of software code to fly this aircraft and to let it operate. Now, how much do you think the S-Class Mercedes would have? Any guess? It's a shy audience today. 200 million lines of software code. And that's what it takes to get an S-Class Mercedes to operate today. And by the time we get to autonomous vehicles, we're going to be looking at 300 to 350 million lines of software code. And as you know, this is not just software sitting in the car. This is a part of the expression of performance of the vehicle. The car, whether it's the S-Class Mercedes or equivalent products, their performance is not just determined by the physical attributes, not by the curb mass of the car alone, not by the engine, not by the horsepower, but by the way the electronic systems and the software get the car to work. And of course, today when we sit in the car, we look for the car to do much more than just take us from point A to point B, even if it's going to be with great speed and great acceleration. We want to communicate, we want to connect, we want to be entertained. So I think the products have become complicated, and they're therefore brought in this whole idea that the final product is a manifestation of both the hardware and the software of how we get this to work. Now, taking this together now, what would you think, therefore, is the expectation today of a VP of manufacturing from a large industry? It doesn't have to be automotive. If you take this journey that we've come through, you can expect that he wants, or she wants, large-scale manufacturing. They want to operate with constrained capital and efficient use of investment and resources. They want flexible production. They want to manage high variety. They want excellent quality. They want to be able to personalize products and work to a lot size of one. They want to deal with complex products, and they want to deal with the global supply chain. In other words, they want all of this. Now, if this is the challenge that we're going to face to enhance productivity in manufacturing, I, for one, don't have any special remedy or promise. But over the last few years, I've had the privilege of being on the advisory board of the Fraunhofer Institutes in Germany. And I have come to see close hand how the Germans particularly have been systematically advancing this whole philosophy of Industry 4.0. I know there is going to be a lot of discussion of Industry 4.0 later today. I will not delve into the depths of this, other than to say that this is an aggregation of the kinds of skills, technologies, tools that are going to make it possible for us to have it all of the things that we've just been talking about. And I think this approach to dealing with things on a cyber-physical level has immense promise for advancing productivity in manufacturing in the years ahead. I think the building blocks are well known. It deals with big data, openness, quality systems, autonomous self-regulating machines, dealing with uncertainty, and managing diversity and variety. I think there is an important opportunity for India, and this is where I'd like to close. I truly hope that India takes on this as a philosophical challenge, just as we have in the past taken on things like mass manufacturing or lean operations in our challenge. This is likely to be a defining platform as we go into the next couple of decades for manufacturing. And I believe it has some unique opportunities for India. For one, I believe an environment operated by Industry 4.0 will facilitate what I call democratization of manufacturing. It could, to some extent, disarm the scale advantage. You know, particularly on a global stage, when we look at India vis-a-vis China, we're repeatedly outdone by their ability to invest in scale, no doubt helped by their access to low-cost capital and other advantages they enjoy. But the net result is they very often outmaneuver us on scale. We need levers that can disarm the scale advantage, and in some ways, Industry 4.0 can be one. Industry 4.0 has a very high dependence on data and software. India, as a country with a large talent pool in this domain, can make a very important contribution, not just for Indian manufacturing, but for global manufacturing. Industry 4.0 acknowledges that there would be a very high rate of reconfiguration, redesign of products. It's not building millions of the same widgets over and over again. And here again, every time we increase the ratio of redesign to the final output, India has a better advantage. We have a large talent pool of engineers, manufacturing technologists who are savvy at being able to quickly do reconfigure. In other words, the more you increase the ratio of human input to final manufacture output, I think it plays to India's advantage. And finally, I think it is a contributor to managing a frugal enterprise. India needs cost-effective solutions. To give you an example, I'm told by somebody who's been involved in the digital transformation journey for India that it took Airtel, or it takes Airtel, something like 2,100 rupees to add each new client to their cellular service. Now that Reliance Jio has come in, they're adding a new client to their cellular service for 180 rupees. 2,100 rupees has gone down to 180 rupees. And how do they do this? Because of the digital transformation. The guy does it with a smartphone, with small peripheral accessories that do fingerprint reading and linkage to an Aadhaar database. Now, if we can take these kinds of concepts to manufacturing, we have to now start to think about low-cost peripherals, leveraging of standard platforms that are high-powered but cost-effective. And we have to take this in deploying solutions for the supply chain, for in-plant operations, and of course, to the delivery of systems. I believe, like every one of you here, you're here because you're passionate about manufacturing. I truly hope that in this next couple of decades, hopefully with the advent of a new industrial policy, and hopefully with a lot of Indian industry taking on one or other aspects, and hopefully many aspects of Industry 4.0, we can truly close the gap that I talked about at the outset, where manufacturing has still languished in its contribution to GDP. I think if India can count on manufacturing to step up to its contribution to GDP the way our software and services sector has stepped up, I think India will be a formidable economic power in the world ahead. Thank you.